Imagine you are enjoying a sunny afternoon in the park. Suddenly, a deafening boom shakes the ground. Like an explosion in the distance, you look up startled, but the sky is clear. What you just experienced was a sonic boom. Sonic booms are powerful sound waves produced by objects traveling faster than the speed of sound. They're often associated with military jets, but other things like meteoroids can also create them. As sound travels through the air as waves. These waves are essentially vibrations that move through the medium of air, creating a ripple effect that we can hear. Imagine throwing a stone into a pond and watching the ripples spread out. Sound waves behave in a similar manner, but in 3 dimensions. These waves move at a specific speed, which we call the speed of sound. This speed can vary depending on the medium through which the sound is traveling. For instance, sound travels faster in water and even faster in solids like metal. However, in the air, the speed of sound is relatively constant under standard conditions. At sea level, the speed of sound is about 767 miles per hour. This speed can change with altitude and temperature. For example, at higher altitudes where the air is thinner, the speed of sound decreases. Conversely, in warmer air, sound waves can travel faster. When an object, like an aeroplane, travels faster than this speed, it is said to break the sound barrier. This phenomenon was first achieved by Chuck Yeager in 1947, piloting the Bell X-1 aircraft. Breaking the sound barrier was a significant milestone in aviation history, opening the door to supersonic flight. As an object approaches the speed of sound, the sound waves it creates get compressed together. This compression leads to a dramatic increase in air pressure and density in front of the object, forming what is known as a shock wave. The closer the object gets to the speed of sound, the more pronounced this effect becomes. This creates a sound barrier of high pressure that the object must push through. When the object finally surpasses the speed of sound, it breaks through this barrier, often resulting in a sonic boom. This boom is a loud, explosive noise caused by the rapid release of pressure, marking the moment the sound barrier is broken. Think of a stone being thrown into a still pond. The stone creates ripples that spread out in circles. Sound waves work in a similar way, spreading out from the source of the sound. When an object moves faster than the speed of sound, it actually moves faster than the sound waves it is creating. This causes the sound waves to pile up on top of each other, creating a shock wave. Section 4. The physics of a sonic boom. When an aircraft travels faster than the speed of sound, it creates a phenomenon known as a sonic boom. This is not just a loud noise, but a complex interaction of physics and atmospheric conditions. As the aircraft moves, it compresses the air in front of it, creating a series of pressure waves. When these waves merge, they form a shock wave. This shock wave is what we hear as a sonic boom. It's a sudden, intense change in air pressure. The pressure difference is so significant that it can cause windows to shatter and buildings to shake. This rapid fluctuation in pressure is what makes the sonic boom so powerful and startling. The boom isn't a one-time event, it's a continuous effect as long as the object is traveling faster than the speed of sound. This means that as long as the aircraft maintains its supersonic speed, it will keep generating sonic booms. The shape of this shock wave is conical, with the object at the tip of the cone. This cone is known as the Mach cone, and its angle depends on the speed of the aircraft. The faster the aircraft, the narrower the cone. As this cone passes over an observer on the ground, they hear the sonic boom. The experience can be quite dramatic, often described as a thunderclap or an explosion. Understanding the physics behind it helps us appreciate the incredible speeds and forces at play. Section 5. The impact of sonic booms. Sonic booms are a fascinating yet disruptive phenomenon that occurs when an aircraft travels faster than the speed of sound, creating shock waves that can be heard and felt on the ground. Sonic booms can be more than just startling. They can be incredibly loud, often compared to the sound of an explosion or a thunderclap. This sudden noise can cause panic and confusion among people who are not expecting it. They can have real-world consequences, affecting both the environment and human activities. For instance, the noise pollution from sonic booms can disrupt wildlife, interfere with communication, and even impact human health by causing stress and anxiety. The intense pressure changes can cause damage to buildings and other structures. Windows can shatter and the structural integrity of buildings can be compromised, leading to costly repairs and potential safety hazards. This is one reason why supersonic flights are often restricted over land. The potential for damage and disruption has led to strict regulations limiting where and when these high-speed flights can occur. Today, scientists and engineers are working on ways to reduce or mitigate the effects of sonic booms. Research is focused on understanding the physics of shockwaves and developing technologies that can minimize their impact. New designs for supersonic aircraft aim to lessen the intensity of the shockwave, making these aircraft quieter and more environmentally friendly. Innovations in aerodynamics and materials science are paving the way for a new era of supersonic travel, making supersonic flight over land a real possibility in the future. With continued advancements, we may soon see a time when the benefits of supersonic travel can be enjoyed without the disruptive impact of sonic booms.